Ready for a fast-paced, demo-heavy session? Okay, let's introduce Rainer Stropek, co-founder and CEO of the company Software Architects, who will talk about the Singe page revolution with WebAssembly and ASP.NET Blazor. The floor is yours, Rainer.
Thank you very much for this warm welcome here on the stage at TechEd Netherlands. I'm really glad to be here. I have been a speaker at TechEd in the past, but it was always in Belgium. So I'm really glad to be now here today in the Netherlands. And I'm going to talk about a topic which is quite interesting for a lot of .NET developers out there. It's about Blazor. It's about the single-page application revolution that maybe WebAssembly can bring to .NET developers. Let me mention at the beginning, before we dive right into the subject, where you can get all the samples that I'm going to show you, where you can get them from. First, I'm running a community documentation site about Blazor. It's called learnblazor.com. There you can download my entire slide deck, and you can find all the samples and a lot of description about how all these things work. And you can also go to GitHub. There you will find the source code of this website. And of course, the samples with all the source files. You can run them from them, and you can experiment and recap what I'm going to tell you in the next 60 minutes. So, what are you going to see in the next 60 minutes? I will start by describing a little bit the situation that we are currently in the web development world when we are .NET developers. We are going to talk about the why. Why is this important? Why is it relevant? And what is the fundamental idea of this Blazor thing? That will be maybe 10 minutes or so. And the rest of the 50 minutes, we will stay in Visual Studio. I will show you lots of code. We are going to write a little bit of code. I'm going to do a lot of debugging here live on stage. And it might become funny for you because I'm going to use a lot of preview software. So maybe some things will go wrong. We will see. But hopefully, most of the demos will work. So you will see most of this session live demos, running code, writing code, debugging code in Visual Studio and Chrome. So let's start with the why. Why is Blazor relevant, and why am I so excited about this Blazor thing? You see, this is where my heritage is. This is where I come from. When I graduated from computer science school approximately 25 years ago, I was primarily a C++ programmer. This is what I really love to do. And a few years after that, I learned about C#, and I immediately fell in love with this language. It's a managed language, it's so productive, and I have been using it since the very early days of the first technical preview, so I like C#. However, one thing that I was always missing in the early days of C# was, how can I target the browser? I want to write browser applications, and a few years after C# came onto the market, we had something which we all know and, well, loved at that time, but right now we are not that in a love relationship, more in a hate relationship, this Silverlight thing. Microsoft took C# and brought C# into the browser on the client side, not on the server side. At that time, I was really, really excited about this because it promised me, as a C# developer, to be able to write client-side web applications in the language that I loved. We all know how things went, and we still, in my company, have a few lines of Silverlight code that we have to support for another few years. But at the end of the day, Silverlight wasn't that great of it wasn't that great, the experience. We all know why. Then I personally changed my focus a little bit. So I started looking heavily into JavaScript development. At the beginning, I didn't like it very much. But then I found TypeScript. And yeah, my opinion to client-side development changed. So TypeScript is a nice language. For me, as a C# or C++ developer, I immediately liked what I saw. And up till today, I'm writing approximately half of my time C# code, and the other half of my time I'm writing TypeScript code. OK, that's fine, but I need a framework. And of course, there is no .NET framework for TypeScript. So I began looking at frameworks like AngularJS and Node.js on the server side, and now, of course, Angular. Why did I look at JavaScript and TypeScript on the server side, you know what? I like using a single framework on both sides. In many projects, I am the one who writes the code for the back end and the front end. And in that case, I love to share code. I love to reuse code. Think of, I don't know, some validation procedures, some validation logic for forms and things like that. So this was the reason why I have been diving into Node.js. And to be honest, I like Node.js, but still, I would like to program more C# because I like C# more personally. So this is the situation. And then something interesting happened, WebAssembly. So what's this WebAssembly stuff? There was a separate session about WebAssembly, so I will keep the introduction to WebAssembly very, very short, because maybe you have seen this session. I think it was Christian who delivered this session. WebAssembly, in short, it is a binary instruction format for a stack-based VM that can run essentially everywhere. However, mainly it has been built for the browser. So it is a VM that can run binary code in the browser. That's the important thing. And it is a compilation target for higher level languages like C++ and Rust. So you can write applications in C++, compile it not to machine language, but you compile it to WebAssembly, and then you can take the resulting binary and run it in the browser. Technically speaking, you are not limited to the browser. There could also be a WebAssembly implementation that enables you to run your C++ code in a portable way in the console on a server, for instance. But today in this talk, I will focus on WebAssembly for the browser. It is an open standard, so WebAssembly is not another Silverlight. It is part of the standard of the W3C standard, so it is implemented in all major browsers, on all major operating systems, without plugins. And that's a very important one, because when I first heard about WebAssembly, I immediately got this feeling in my stomach reminding me of Silverlight, and I didn't like that feeling very much. But yeah, it is different nowadays. And why? Why was WebAssembly primarily invented? Well, first, because of performance. We need higher performance in the browser, especially for graphic-intensive applications like CAD applications or games and things like that. And at the same time, we don't want to download unsafe binaries onto our machines, and this is the reason why WebAssembly was invented. Okay, some facts about WebAssembly. It's very much different from the intermediate language that you might know from the .NET framework. It's much simpler. It has linear memory. There is no garbage collection. So it is more similar to assembler language than to intermediate language. From WebAssembly, you cannot today access the DOM directly. So if you run something in a WebAssembly VM, you cannot manipulate the browser's DOM. So there is no UI for WebAssembly. Okay. So what's the point? If we can run some bytes in the browser, but we cannot have a UI, I mean, there are only very few applications that would benefit from that. But luckily, we have JavaScript Interop. So what you can do in WebAssembly, you can interop, you can call JavaScript methods, and these JavaScript methods, they can manipulate the DOM. So what you can do is you can somehow tell a little piece of JavaScript, please paint something on the screen, and then the JavaScript will interact with the browser and everything's fine. So you have a high-performance VM that can run games, CAD applications, and so on. You know, if we can compile C++ to WebAssembly, and if we know that .NET, the lowest levels of .NET are written in C++, can't we just take the .NET Common Language runtime, compile it to WebAssembly, and suddenly have our good old friend .NET CLR directly in the browser? Somebody could start such a community project, but it's not necessary because the Mono team already did. The Mono team did exactly that. They took the C++ code off the .NET Common Language runtime, they compiled it, and they tried running it on top of WebAssembly, and it worked. That's the basic foundation of Blazor. So sometimes in 2017, there was an early prototype where you could write a Hello World application in C# and run it in the browser without a plugin based on open standard. Wow, and that raised my attention. I was really excited because I could see the potential that's in there for somebody who likes C# and .NET. Now, Blazor sits on top of this technology. It is built on the mono WASM runtime. So Blazor is not using the .NET Core bits, it's using the mono runtime. Why? Well, the mono team was first, so they already have a big investment in WebAssembly, so the Blazor team decided to build on top of that. But generally speaking, it doesn't need to stay like that. It's really, it's transparent for us as Blazor users, whether it uses mono or whether it uses any other CLR implementation. We simply don't care. The important thing is that we get the common language runtime into the browser. Next, the Blazor team decided that they need some kind of template language with which you can specify how your UI should look like. And of course, in the browser, that's HTML, but somehow we have to add things like data binding and all these nice things that we know from Vue and React and Angular, and they decided to go for the Razor language, so this is where the name comes from. Blazor is browser plus Razor. Okay, so they took the Razor engine, which is part of ASP.NET Core, let's say generally, .NET Core, and they also included it in the package. So the next thing that came on top of it is, of course, the .NET Core runtime and the library. You get all the features of the .NET Core base class library, of .NET standard, and you can run it nearly without limitation. There are a few limitations, but in general, the limitations aren't that bad. You can run it in the browser, again, without a plugin, based on the W3C standard. Well, that's the whole idea of Blazor. So that really raised my attention, because there are a lot of things on this slide or inside the Blazor package that I like to use. I like Razor, I like the .NET Core framework, and I like C#. So what does Blazor promise? It promises us, as developers, to be able to build web applications in the browser client for mobile and full client with C# and .NET on top of the original CLR. That was my introduction, and I hope you are now curious to see what Blazor is possible to do, what Blazor can do, is able to do. So the rest of this session, we are going to just talk about demos, and I'm going to do a lot of debugging and coding, okay? So this will be, well, maybe I will go back to 1 or 2 slides after that, but in generally, we're done with PowerPoint, and we'll immediately go into my first demo. So let me quickly spin up a command line here. So give me feedback. Is the font size okay? Larger? Is it okay? Larger, okay. You will get a larger font. That's absolutely no problem. Okay like that? Okay, thank you. So let's quickly create a folder, mkdir hello Blazor. And let's create a new Blazor app. And I'm going to start on the command line. Of course, I could do the same thing in Visual Studio too, but you know, Visual Studio does a lot of Harry Potter programming, fairy dust, magic, and so on. I would like to show you what's going on behind the scenes, so therefore, I'm going to create our first Blazor app directly here in the console. So we can say .NET New, and I've installed the templates for Blazor. I will zoom in a little bit. Here you see them. Unfortunately, with the large font, it's a little bit messy here on the screen, but I think you get the point. There are different templates for Blazor, and they are fully supported in the .NET CLI, so we can go for this one. We will create a basic Blazor app directly here in my console. .NET New Blazor. This will create a bunch of source files. It will do a .NET restore. That's fine. By the way, I'm using here the latest preview of Blazor. It's 0.6.1 preview. It is a preview of an experimental project. So just that you know how experimental and bleeding edge we are here. So now we got some, let's zoom in a little bit. We got some C# files. Remember, we are doing browser development here. And we don't get JavaScript, we get C# files, we get a CS_proj file and so on. We will take a look at these files in a second. First, let's create a solution here. Okay, let's .NET new solution. This is what I wanted to do. And let's do a .NET solution add Blazor. No, hello Blazor was it called. Yes, exactly. So now we have a solution file too. We have a CS_proj and a solution file. And the first thing that I'm going to do is I'm going to build this guy, .NET build. It's just the .NET tooling. Should be done in a second. Yep, looks good. 0 warnings, 0 errors, that looks good. Next one, I'm going to do a .NET publish. Let's do a release version, and let's output everything into the out directory. So now I'm going to publish my results, and we will take a look at the resulting files now. So what we got here in our Blazor app, if we take a look at the autonomy of this application, is, as I said, a bunch of C# files, a solution and a CS_proj file, a folder which is called pages, and we will take a look at this folder in a second. And here is our out folder. And I would like to start from the opposite. I will not start with the source code. We'll spend enough time with the source code. I will show you what you get from Blazor that you can use to run your application with. What you essentially get is a folder with a web.config file, which is useful if you want to host your Blazor application in IIS. And at the end of the day, you have a folder with a HTML file, CSS, of course, some sample data, whatever that is, and a folder which is called _framework. And this is where the interesting stuff is in. If we take a look at the _framework folder, we will see that we have a combination of Microsoft-provided JavaScript together with WebAssembly, an _bin folder, and an ASM.js folder. So what's what? The JavaScript part is the JavaScript client-side JavaScript part of Blazor. I told you, WebAssembly cannot talk directly to the DOM. So what Blazor does, it talks to these JavaScript files, and these JavaScript files, they will talk to the DOM. I will show you that live in Chrome in a second. The WASM folder, let's take a look at it, contains the mono WebAssembly runtime. This is the mono runtime. This is the common language runtime written in C++, compiled to WebAssembly. Okay? And finally, if we go to the _bin folder, here it gets really exciting. Because what we see here are standard .NET DLLs. WebAssembly, Blazor in general, Blazor runs standard DLLs. You don't need to recompile your .NET code into a different kind of DLL. You just take .NET standard DLLs, and with the mono WASM runtime, they run directly in the browser. So you have the WebAssembly stuff, you have the mono runtime, and on top you have your .NET, exactly your .NET. So let's try to run this guy. Oh, let's first open our project here in Visual Studio, so you also see that it works nicely here in Visual Studio. I'm using the preview version of Visual Studio 2017. So the very latest bits again. And you see, it opens here in Visual Studio 2017. I have installed the Blazor language services. You see it here. It's just an extension that you can install from the marketplace. And then you have support for Blazor in Visual Studio. So if you want to do exactly the same thing with a GUI instead of the command line, you would say new project. And you could say here, ASP.NET Core Web Application. And in the wizard, here, you see a bunch of templates. Here are a bunch of templates which are Blazor related. So this is the GUI on top of the console that I showed you a second ago. I could have chosen that one and click OK, and it would be exactly the same. And I could also right-click Publish this web application. Let me reopen our Hello Blazor application again. Nice. Here we see the source code, but first we want to run the code and take a look how it looks like from a user's perspective. So again, I'm going to run it, and I'm going to run it with the Blazor CLI, .NET Blazor serve. .NET Blazor serve on the command line. Let me get rid of that one. I started it in Visual Studio. I'm very sorry. I would have to close Visual Studio again, otherwise they interfere, so I will run it from Visual Studio. That's fine too. So this is essentially Visual Studio calling .NET Blazor serve. It will come up in a console application. As I said, it just calls .NET Blazor serve. And in a few seconds, we crash. That's not good. So let me quickly clean up. Yes. So let's rebuild this guy. Otherwise, I'll take one of my prepared samples, but it should work. Yes, much better. So now we have .NET Blazor serve, and this is now our Blazor application, okay? The important thing is that we have a single-page app. It is nothing running on the server. You can host your Blazor application on a very stupid static file web server. You can run it on an Nginx server. You can go to Azure, just copy-paste the folder that I showed you before, this publish out folder, even without the web.config. Just put this folder with the index.html in the root directory, copy it on Azure Blob Storage, and it will just run. You do not need any intelligence on the server. It's a single-page app framework. So let's take a look what the browser pulls down from the server. I will open in the Chrome Developer Tools the Networking tab and refresh our application, and then we will zoom in a little bit to see what's going on. So I Control F5'd our application, and I will zoom in a little bit. So what do we see? What we see is first here and here the mono runtime. This is the mono WASM runtime with a tiny bit of JavaScript on top of it. This is our foundation if you want. Once this mono runtime was loaded, it can, you see it down here, load the DLLs from the server. So it will load your .NET standard DLLs and execute them on top of the mono WASM runtime. And of course, you can use the JavaScript and CSS frameworks that you like to use. For instance, in this case, what the standard template, if you call .NET New, adds is Bootstrap, the Bootstrap CSS framework. So on top of this, it loads standard HTML, CSS, image files, whatever you need. This is what we currently see. And if you wonder, well, these numbers are pretty large because we are downloading essentially, for instance here, the entire MS Corelib DLL, and it's pretty large, you are right. Blazor has not been tailored to the minimum footprint. Blazor is currently an experimental project, and if you build a Blazor application and you run it, you will probably end up with files that you have to download in the rough size of a few megabytes. So we are not talking about a few kilobytes like with many JavaScript frameworks. We are talking in the megabytes currently. But there is a lot of potential that can be, so that these files can be reduced in size. For instance, some tree shaking and so on, and the Blazor team is actively working on that, but it's an experimental project, and they are currently focused on the features and not so much on the optimization part. But in general, this is what's going on. And if we clean this guy here, and if I navigate between the different pages, you see the only server communication is the favorite icon and some REST APIs where it's downloading some data from some web APIs, for instance. Nothing else is going on. So it's really a single-page app framework like Vue, like React, or like Angular. This is essentially what comes out of the Blazor framework. OK. Now let's take a look at a different option. If I'm going back here and start another CMD, let's create another folder. Let's say Hello Blazor Server. Hello Blazor Server. And copy this folder, go to Visual Studio again, and this time I'm going to show you the creation of a project directly here in Visual Studio, and I would like to put it here. The name of the solution doesn't matter, so we'll just go with web something. Then you will see that we have on the one hand side the Blazor template, which gives us the single page app, but on the other side, and that's interesting, we have this ASP.NET Core hosted version of Blazor. And this is especially interesting if you want to use C# and .NET on the server and on the client with the Blazor framework. What this template essentially gives you, let me zoom in here a little bit, it gives you the Blazor client application. This is exactly what you have seen before. This will create the WASM runtime and the DLLs which run on the client. But in addition to that, you will get an ASP.NET Core application where you could, for instance, place your web APIs. And the cool thing now is that you can share logic just by adding a project reference. You can add logic based on a .NET standard class library. Maybe you have existing logic in a .NET standard class library, and you can just refer to this logic from the server side and from the client side, and you have beautiful code reviews on the client and on the server. That really fascinated me when I've seen it for the first time, because this is a use case that I regularly have. In addition to that, if we take a look at the startup code here for the server application, you will see that hosting a single-page Blazor app in ASP.NET Core is really, really simple. You just have a ready-made middleware, this use Blazor stuff, and what this use Blazor stuff does, it's just taking the single-page app stuff, so the DLL, the WASMs, the JavaScript parts, and offer static file hosting for these files. So you have a single solution with client-side, server-side, and shared library, and you can just F5 into it. So if I select, for instance, here the web application server again, and if I run this guy, it will run the server, it will compile the client, put the client code into the server output directory, and you get one folder that you can take and, for instance, put up in Azure App Services to run your combined C# application with the client part and the server part. So what you see here is now the client for the UI. And if we take a look at the network tab here and click on Fetch Data, you will see that here our single-page app, Blazor, calls a web API, ASP.NET Core, in the same project. And we share the same data structure, the same model, the same logic from server and client side. OK? So this is the variant where you are hosting your Blazor app in ASP.NET Core. You have the choice. Okay? It depends. Sometimes you only have a client. Sometimes you want to share both things in a single solution. Of course, because Blazor is a single-page app with just static files or a standard .NET application, you can also very simple host it, for instance, in a Docker container. Just take the published output folder, put it in a Docker container, Nginx or one of the .NET images that Microsoft provides, and it will nicely run on top of your Docker infrastructure in Kubernetes or wherever you want to run it. So you have all the hosting options that you have in the Node.js, Angular, React world. It's exactly the same here with C# and .NET. Now, let's take a closer look at how you program with Blazor. I have created a small sample application, and I would like to do some code walkthrough together with you so you get an impression how powerful this framework already is and where its limitations are. So let's take a look. Let's first take a look. Oh, I was too fast. I would like to go back to my Hello Blazor. I'm sorry. I was a little bit too fast closing this application, but it's rather quickly reopened. Here it is. Let's take a look at one of the most simple code pieces that I can show you. This is a Blazor template, and you probably immediately understand the code by just looking at it. What you see here is a mixture of HTML. Yes, it's HTML. You're writing HTML, not a separate language. You are not using XAML or something like this. In Blazor, you are writing HTML. This will be exactly the HTML that your browser will get. And down here, we have some C# code. This C# code can be embedded in the CS.html file, but of course, you can also split the view part, HTML, and the logic part in a kind of MVVM, MVP, MVC kind of style. Okay? That's completely up to you. Blazor is agnostic to how you separate view from logic. To keep things simple and to be able to show you code and view on the same page, I will mix here C# and view on this in the same files. But if you don't like that, feel free to change that in your production code. You will see that in the HTML template, you can reference, for instance, properties or fields. You see the field down here just by adding the ampersand. You can do event handling like the onClick handler and immediately call this increment count thing. And if you do that and you change the property inside of your C# code, Blazor contains automatic data binding and change recognition, so it detects that you are changing the current count, and it will automatically refresh the DOM. You do not need to write any kind of logic or any kind of code to manually update the DOM. This is done by Blazor in the background. But please remember, this code down here is running in C#, so in WebAssembly. It cannot directly manipulate the DOM, but it will go through the JavaScript part of Blazor to do the changes in the DOM, and I will show you that in a few minutes directly in the Chrome debugger. But that's the core idea of this whole, let's say, template language. So what's happening if I build this guy? If we take a look behind the scenes, yep, exactly. Here in the Hello Blazor directory, if I go one up and I go into Object and Debug and Net Standard and Pages, and here you will see that we have some generated code files. Okay? So let's open counter.g.cs to see what's going on behind the scenes, and let's put the template and the C# source code side by side. Let's make it a little bit smaller here on the right-hand side, and I think you already get the idea. I have to zoom out a little bit, so I think you still get the idea. You do not need to read all the details. But the point is, here we have our counter.cs.html, and if we take a look what's happening behind the scenes, the compiler, the Blazor compiler, will compile your HTML template into C# code. See that one? So what you will get, if I zoom in a little bit, is a bunch of calls to methods like addMarkupContent and OpenElement and so on, and here you will recognize your HTML templates. For those of you who, like me, do a lot of Angular development too, that should look familiar for you, doesn't it? What does Angular do if you write an Angular template? The Angular compiler compiles the Angular template into JavaScript code. You don't have HTML anymore. It's compiled, and Razor does exactly the same thing. What they do is they are taking the Razor templates and generate C# codes from that. What we also see, if we zoom in a little bit, we will see that each CS.html page becomes a class. And all these classes are derived from a common base class, which is called Blazor component. And this Blazor component has one important method in it, which is called build a render tree. And what this essentially does, it's building a kind of virtual DOM in the WebAssembly part of Blazor. And this virtual DOM is then continuously monitored for changes. If something changes, it communicates these changes to the JavaScript part of Blazor, and JavaScript then takes these changes and propagates them to the DOM. That is how all this stuff works, okay? Of course, you do not need to absolutely use the C# templating or the Razor templating of Blazor. You can write your own application, derive it, your own class, derive it from Blazor component, and build any arbitrary code in build render tree. I have an example for that. It's exactly here. What I did here is I would like to display a tic-tac-toe board. So it is rather boring to type in the TR and TD and table tags to get a 3x3 board. So what I essentially did is I manually implemented the build render tree method, and I'm using some logic to algorithmically build the HTML in C#. You get the idea? For instance, in my company, we, in many cases, do modal-driven development. So we have some kind of configuration stuff, and we generate the UI from this configuration, which is read at runtime. So what you could do is you could take this modal and generate the HTML that is served to the browser programmatically. That's the whole point of this render tree and this virtual DOM, which exists in the WASM part, not in the browser part. So now you know behind the scenes what you get is a nice little class, and your HTML template in reality becomes C# code. Now let me quickly give you a quick tour around this template language. It will be really quick, and you can take a look at the documentation of Blazor. You can take a look at my site, Learn Blazor, or even contribute to this community documentation. But still, I would like to give you an impression what this language can do. Let's start with some very simple things. And I told you I'm also an Angular developer, so I added some comments for you. Maybe some of you are also Angular developers, just to compare these two frameworks and to maybe find similarities. It's always easier for me to learn a new framework if I recognize some similarities with other frameworks that I already know. Now, let's see. Here, you see a very simple one. It's just a one-way binding. And you can see that you can add logic by just adding arbitrary C# constructs, like an if statement, a for loop. You can just add any logic. Keep in mind, I know that in reality you should not mix logic and view, but still sometimes you have to have a little bit of logic inside the view, for instance, by iterating over a collection to generate a list, a dynamic part of the UI, and this is what the if stuff does here. Now that you know that these templates are rendered into C# code, you should already understand where these if statements go. Well, they go into the generated class. So this is not a new language. This is C#. This is just injected in the generated C# classes. You can also see that you have some interesting things, for instance, some conditionally hiding of things. You can do things like style binding, so you can do data binding into styles or classes to conditionally format your code depending on some Boolean properties or string properties or whatever you want to do. Of course, you can add arbitrary complex expressions, like, for instance, this inline if construct directly here in the template. And here you see a loop displaying a list of numbers, for instance, by just using a for each statement. This is the for each statement that you know and love. Do you want to add some link query here? That's perfectly fine. You can add a link query here, and it will do all the magic of change recognition and so on. Okay. Well, what's about two-way binding? Two-way binding is done with the keyword bind. So by specifying bind on an input element, for instance, you establish a two-way binding. If you change the content in C#, the DOM is automatically updated. If you change the content in the DOM by entering code in a web form, for instance, you're automatically sending this stuff back into the C# code. And the JavaScript part of Blazor does the magic. So you do not need to write JavaScript code to, for instance, react on an on-change event or an on-click event in the button or things like that. This is done by the JavaScript part of Blazor. And then they will take the information, for instance, the changed value in the input field, translate it into WebAssembly, and in WebAssembly, it will put the changes into your string. So it seems to you that this name, let me make that a little bit smaller. It's not important that you see the comment here, but this is the HTML part, and somewhere down there, believe me, if you are sitting in the back of the room, this is just a C# string, and it translates the JavaScript DOM string input from the field into the C# variable of type string, and the whole marshalling stuff is done by Blazor for you. That's the whole idea of this two-way binding. And if you take a look later on, if you have the time, take a look at these samples, you will find out that you have some nice little things like, for instance, format strings. You will see, if I scroll down a little bit, that things like select drop boxes support C# enums. So you can have an enum and just add a combo box with the enum values, and all these things, they are just there. Okay? Two-way binding. Next one. Event binding. Any kind of JavaScript event, like onClick or onChange, they just exist. They continue to exist. But the point is that you do not need a JavaScript event handler. But you are wiring up your JavaScript click event with your C# clicked method. This is now a method, you see it down here, in C#. And again, the event is translated from JavaScript DOM into WebAssembly and so on, and it will trigger your C# code. Of course, you can also use things like lambda expressions, if you like actions, and not from the very beginning, but nowadays Blazor already is able to do that, async programming with task of t and async await is fully supported. So you can have async event handlers for click events and anything else that you would like to do. So if you are an experienced C# programmer like I am, and you know async programming in C#, that is now translated into the browser, and it works together with the whole DOM thing. That even works, I would like to draw your attention to this line here, that even works across components. So what you can do is you can add one component into the other. So you can nest the components. And here you see that I have created a custom event in my child component. Let's take a look in this child component. And you will see that this custom event, again, is a very nice thing. It's an action. An action of t or a func of t is just a lambda, a delegate, technically speaking. And you can use these delegates, and it continues to work as you are used to working with all these things. So this was event binding. Let's take a look at the initialize stuff. This one will be fast. You have a bunch of, see it here, a bunch of abstract lifecycle methods, like in this example on init, but there are more lifecycle methods like that, which are automatically called on your component whenever something interesting happens, like when the component is initially rendered, when some parameters are changed, and so on. So you can override some methods. Down here, you see the parameter set, for instance. You can override some methods, and these methods will inform your component that something has happened, and you can decide what you want to do with that. And last but not least, let's take a look at that one. In some cases, maybe Blazor will not automatically recognize that your internal state, in that case the current value property, has changed. I consciously took the timer class from C#, and the timer class will not automatically trigger a data binding run in Blazor. So if you have such a situation where you have some code where you change your state, but Blazor doesn't recognize the state change, you always have the possibility to call a method which is called state has changed, and that will trigger data binding, so you can manually update the display. Then Blazor will diff the virtual DOM. It will translate potential changes to JavaScript, and the JavaScript will then change the DOM. Okay? Nice. Now, let's try that in the debugger. Let's run this sample. and have a little fun with the debugger here. I will start the two-way data binding sample that you have seen a few minutes ago. Here is the two-way data binding. And I will make it a little bit larger, and I will open up the Chrome debugger. Yep, and that's good. And then we will take down here this notification. It says, you are an administrator. What I can do here is I can say, break on node removal. So I will tell Chrome that whenever somebody removes this DOM node, please make a breakpoint and stop wherever you are in the JavaScript part. So it's already in breakpoint, and now I'm going to sources and change this button here. This button has a two-way binding into C#. So in C#, it will change a Boolean property. And this statement down there has a dependency, so it will remove the node if the Boolean property in C# changes. Let's see what's happening. Click. Now we hit a breakpoint. Let's pretty print this stuff. And what I would like to show you here is essentially here the call stack. You will see that we have down there, you can read it from the back, and I have to zoom in a little bit, just believe me. This is a global event handler that we did not register. This is a global event handler that Blazor registered. Then our event clicking of the checkbox traveled through mono and the WebAssembly runtime into C#. Then arbitrary C# code was executed, and the CLR, the Blazor stuff, recognized that we have changed a property which has a two-way binding, sorry, in that case a one-way binding, into our DOM. And so it executes, again, some JavaScript stuff without us seeing anything here, and it executes a so-called render batch. So what's happening in C#, in WASM, it generates a binary data structure with some instructions telling the JavaScript part what to do with the DOM. Essentially, it contains an instruction, please remove this paragraph. And then in JavaScript, this render batch is executed, and this paragraph is removed. So we triggered the change of the DOM from C#, it traveled through JavaScript, and did the change as we requested to. We can also do some other interesting things. For instance, we can, let me stop this example here and switch to my REST API example here and run this guy. In this case, again, I would like to show you how JavaScript localhost 5000 interop basic. This is what I wanted to have. In this case, I would like to show you again a combination of JavaScript and C#, but this time I've written the JavaScript code myself. Because, you know, when I saw Blazor for the first time, I was fascinated by the possibility to write C#, but I immediately knew that this will not be enough. Imagine that you would like to use this great JavaScript framework. Maybe this piece, for instance, I have an example here with the Kendo framework from Progress. I took an open source part of the Progress framework, and I just want to use this existing great JavaScript library. And I know that Blazor has some limitations where I cannot directly talk with this component because I can wait for another few months until the component vendor will come up with a native integration in Blazor. So what do I do if I have to have a kind of hybrid applications where some pieces of logic are written in JavaScript and some pieces are written in C#? And this is where Interop comes in. Let me show you the code, and then I'm going to show you how this code looks like in the debugger. What I did is I added here in the index.html a little bit of arbitrary JavaScript code. So this is some JavaScript code that I added manually. I have written this JavaScript code. And it says, my window, my global object, should have a JavaScript method asynchronously, and it contains the method say. So how can I call this arbitrary JavaScript methods from C#? And it turns out that this is pretty easy. If I go to my CS.html, the only thing that I have to do is I say JS runtime, invoke async, name of the method, and give it any kind of parameters. And that's the beauty here. If you have existing JavaScript code, you do not need to rewrite it in C#. You can just call it from C#. And you can not just add string parameters here, but as you can see here, you can add rather complex C# classes, and Blazor will turn them automatically into JSON. It will travel through the WASM border, and you will have the JSON result available in JavaScript, and you can do interesting things with that. Okay? And it works the other way around too. If you have, for instance, a little bit of C# code that you would like to call from JavaScript, the only thing that you have to do is you have to add an attribute, JS invocable, that will register the method with the Blazor JavaScript Interop stuff. And then, if you take a look at another piece of JavaScript that I did exactly here, the only thing that you have to specify is .NET.invoke method async, give it the name of the DLL, and give it the name of the registered method, and you immediately call your C# method directly from within JavaScript. So JavaScript Interop is a really important thing, and if you have the time, take a look at this example. It demonstrates how to use a non-trivial existing JavaScript component like the autocomplete combo box with data binding to a REST API and all this stuff directly with JavaScript Interop. So these non-trivial use cases also work. I'm quite sure that you might ask yourself, well, I know from Angular or React that there are things like a router or dependency injection and so on. Are they present in Blazor too? And the answer is yes. I only have 60 minutes, so I cannot show you all the details, all the power of Blazor. But if you want to have dependency injection, it's just there. If you want to have routing, master pages, child elements, and things like that, they're all there. So it's very similar to what you might know, for instance, from a framework like Angular. The only thing that I would like to explicitly point out is this guy here. Inject is the command that you add to a Blazor template to do dependency injection of a shared service. And this is the shared service that I would like to explicitly mention. It's the HTTP client class that you know from .NET. If you build some single-page applications and you have some REST APIs in the background, you probably want to somehow call these things. So how can you call a REST API in the background? And the answer is with HTTP client. HTTP client in the background in Blazor contains a driver which uses in the background the browser's HTTP implementation, so you are not directly calling from WebAssembly, some networking interface. That's not possible. It's limited by the WebAssembly sandbox. But again, what you do is you are programming against the HTTP client class that you know, and this HTTP client class will then somehow marshal your call through the JavaScript part of Blazor and use the browser's HTTP stack to call the web API, and the result travels the other way back. The beauty here is that you can use your maybe existing code that you already have, which requires the HTTP client. So if you have existing code, for instance, for WPF or UWP or server-side calls of web APIs, you can still use this code because this is the same HTTP client instance that you already use. Only in the background, a different driver is used when it comes to communicate over the wire. This is the HTTP client stuff. In the last 5 minutes, I would like to show you a last slide before we summarize. This is the slide that I would like to show you, because recently the Blazor team had the following thoughts. They thought, hey, we have this Blazor component here. It's running in the UI thread in the browser, and it's communicating with the browser here via JavaScript. So we have to marshal every call, every activity through the WebAssembly boundary to the browser into JavaScript and back. So this is what we already do. wouldn't it be possible to rip out this whole Blazor language and runtime and maybe execute it in a background thread, not on the UI thread? Or to even go one step further and do the following. Take the Blazor thread, run it in .NET on the server, and use WebSockets, SignalR, to do all the DOM changes. It's conceptually exactly the same that we already have. The only thing is now we have a network boundary between the browser's JavaScript and our C# code. And this is what Blazor can do nowadays already with the so-called server-side hosting. Let me quickly do that as my last demo before we summarize. If I go to a new project, and again, I'm going to spin up a new ASP.NET Core web application. And if I zoom in, you will see that you have some server-side Blazor code. Let's give it a run. Let's create it. I will not write code. We'll just start it. That's all we do. And we will debug it in Chrome. OK, let's give it a go. While this guy is compiling, let me show the two differences which are present here when we use this kind of project. Oops. Oops. Come on. It's loading some symbols from the internet. OK, that's fine. Now, it's done. OK. Note that we have a different JavaScript here. This JavaScript is now not optimized for communicating with the WASM sandbox. It's communicating via SignalR with some remote instance of Blazor. And the other thing, on the server side, we are not using use Blazor anymore, but we use server-side Blazor, and that's it. The entire other stuff, all the things that you have seen before, they are identical. That's the only thing. On the server side, it's spinning up some SignalR stuff. On the client side, it's using a different JavaScript. And the result is fascinating, because if we start our network tab again, and we go here to the counter, and if we go to, let me quickly reload this guy, we will see that our application has started a WebSocket connection to the server. And now if we take a look at the frames in this WebSocket connection, and if I click on the button on the client side, you see the binary frames here running around. And if I do that one and that one, so now we see that all my DOM changes travel through SignalR to the client and to the server back. So this is a new kind of deployment for Blazor, and believe it or not, Microsoft has announced that they will ship this version of Blazor even earlier than the single-page-app part of Blazor, because this doesn't require WebAssembly, and WebAssembly is not ready for production yet. So let's summarize. So what? Is it the Angular React Vue killer? Well, I don't think so. I don't think so yet. Currently, JavaScript-based frameworks are super robust. They are mature. The ecosystem is huge. They are very powerful. On the Blazor stuff, we have the power of C#, but the community cannot be compared to the JavaScript community. The tools are immature. Debugging, early prototypes, not really good to demo on stage. But on the other side, if you have a strong investment in C#, if you are a very well-skilled developer in C#, if you have existing C# code and you want to go to the browser, then I think that Blazor is a very interesting option for the future. We have an additional option here. It's not the killer, the system that is killing Angular and Vue and React, definitely not. But it is a powerful option in the future if you decide to use C# or if you have to use C# because of existing knowledge or code. This is what I personally think about the future of this Blazor stuff. Now we had 60 minutes time to take a look at Blazor. If you got curious and you would like to know more about this Blazor stuff, well, one thing is you can go to blazor.net. There you will find the official documentation of this experimental project. I would like to emphasize that. Blazor is not ready for production. It's the right time to experiment, it's the right time to build prototypes, it's the right time to contribute documentation or code or bugs and so on. Blazor is 100% open source and they accept community contributions. You can also go to my site if you want, learnblazor.com, learn-blazor.com. There you will find some additional samples. You will find all the samples that I showed you in this presentation and more. You will find my slide deck. Everything is MIT licensed. Take it, share it, contribute to it, redeliver it, do whatever you want with it. I am excited about this new single-page app framework, and I would like to enlarge the community. That's the reason why I'm investing in this framework, and I really hope that you will take a look at the Blazor framework, and that talk now has maybe raised some attention and some thoughts in your head, and you consider this framework maybe for the projects that you are going to start in the near or midterm future. I would like to say thank you for coming to my presentation. I hope it was an interesting hour with Blazor, WebAssembly, and C# in the browser. I would like to say thank you. My name is Stropek, and I was really happy to deliver this session for you. Thank you, and have a nice Techorama.